Hello everybody, moon cycles and complete orthogonal system. You see, I would like to show you how to calculate some cycles, and also second part of this video, it will be about one math technique. You need to know it. Okay, firstly, I would like to show you Larry Williams sent this website, link for this website, Time Price Research, and look at this. How to calculate these cycles. This is lunar declination, latitude, and composite. I guess this is superposition, declination plus latitude. You see, something is wrong here. Because you see, declination, it changes between minus 25 plus 25, while latitude it's about 5 degrees, 6 degrees, so it should be different scale. Maybe I guess they rescaled these values. Okay, let's do this time solution. I already have downloaded the price history for S&P 500 for last 12 years, and let's calculate it. In ULE, you will find this as angle difference. Set here sun, and declination, position. Okay, so value itself, moon, declination, position. Okay, click calculate. Here it is. This is chart for declination. Next, let's calculate latitude, geolatitude. It is here. Okay, please set. And we need to calculate superposition, L1 plus L2. Okay, calculate. Now you see, because declination it's almost twice, 5 times its bigger value for declination, the superposition it practically will repeat the declination chart. Here it is. They're practically identical. So maybe we need to change the weights. Okay, let's first check how this indicator works, how it forecasts S&P 500. Click this button, and here there is option, this one, continuous events. Here it is. So correlation is 3.2%. You see, it's fast cycle. Maybe we'll set small declination, a small window, maybe a 10. Relative price oscillator with period 10, and click calculate. You see, it's more precise, 5 degrees. So correlation between this indicator L1 plus L2, it's about 5%. So this indicator forecasts S&P 500 with accuracy 5%. Okay, maybe the question is, maybe we can optimize these weights. Maybe we can find the best weights for declination and latitude to get the best forecast. You can do it this way actually. In ULE, simple ULE, this button, click this button, simple ULE. The program will send this model here, and now look at this. I just click optimization, but before that, you see, I need to do this. I need to set target. Set it to 10. We will optimize using relative price oscillator with period 10 trading days, because this is fast cycle. Okay, and now click optimize. So you see the weights are here. I just paste and copy, Ctrl insert. Okay, and now Shift insert. Sorry. So, and click calculate. So this is optimized indicator for this superposition. Let's check how it works. Yeah, no, percentage practically the same. Yeah. Next step. Let's what's next to calculate? Just a sec. Okay, lunar orbital. Let's firstly I will show how to calculate this one. Lunar declination acceleration cycle. This is easy. Just a sec. I will remove all these events. Clicking this button, and now lunar declination, moon declination, and here we can calculate position. Then we calculate speed. Yeah. And then we can calculate acceleration. Acceleration, this is speed of speed. So, okay, how it looks? Yeah, it is. How it forecasts? Minus 5.55%. Minus. It means that we need to make it negative. So this is indicator based on declination acceleration. This one. Okay, ducky. Next. Oh, sorry. This. They won't calculate. Sorry, I do not understand. True and mean lunar orbital speed. You see, true and mean. It usually they mean lunar nodes. Because if they calculate mean north node, it will be always retrograde. Otherwise, if we will calculate actual, if we calculate a true north node, because you see, because lunar orbits, it oscillates a bit. It seems to me they call it nutation. Yeah. Sometimes it can be, it may be direct, and sometimes it can maybe retrograde. So I don't know what is that. It's not north node. So I simply will calculate lunar orbital speed. Okay, do this. I will remove all this. Orbital speed, it means declination, longitude, and speed is here. And click calculate. This one, and now we can check how it works, how it forecasts. Not too much. Next section, I will explain you complete orthogonal system. Actually, this is complete orthogonal system. Sinus, cosine waves, and the harmonics. Let me show you something. Look at this. Here, two waves, red one and blue one. This is vertical line. This is starting point, and this red one, this is sinus wave. It's at 0 point, at a starting point, it's crosses 0 from down to up. And blue one, this is cosine wave. At 0 point, it's equal 1 plus 1, reaches maximum. Next, when sinus wave reaches maximum, plus 1 value, cosine wave, look at this, crosses 0 from up to down, and so on. You see, actually we can take cosine wave as sinus wave, shifted 30 degrees, 90 degrees back. 90 degrees. This is why they call them orthogonal. So these two functions, sinus wave and cosine wave, work very well together. For example, if we take some another, by the way, I don't remember, did I tell you that the period of these functions is the same, it's 35 days. Suppose I found some another wave, sinus wave with period 35 days, the same period. And theory tells you that any of these sinus functions can be explained as a superposition of two waves, sinus wave and cosine waves. You see, I already now know weights for these functions. Here they are. and so clicking calculate, I will get exactly the same function. You see superposition of this two waves, sinus wave and cosine wave, and this is exactly this function. You see some difference. This is because margin. You can play with margin, and you will get the same. Okay, so these two functions form orthogonal system. If we will add harmonics like half cycle, 1/3 cycles, and so on, we will get a complete orthogonal system. Complete, it means that any periodic function with period 35 days can be explained as superposition of this sinus wave, sinus cosine wave, and they harmonics. So I recommend you, by the way, check on our website. Just a sec, I show you. There is special article where I explained all this basic harmonic analysis. Here, very basic on harmonic analysis. And by the way, for example, as an example, I took some function like, okay, just a sec. Okay, you see, I have analyzed this stepping function. Last step, it's 0, 1, and then I tried to build this stepping function using superposition of different sinus cosines waves and they harmonics. This is just sinus wave. This is I have added one harmonic, one overtone, 3 overtones. You see, it's getting close. 4 overtones, 6 overtones, 12 overtones. So this is a full orthogonal system. Now let's apply this knowledge. You see, we will build now a full moon declination model. I will show you what is that. Let's build this cycle moon. Sorry, I will remove this. Moon declination cycle. Here it is, moon declination. Look at this. We'll calculate it, and we can see this moon declination. Yeah, declination. Position. Okay, and you see how this cycle works. Here it is. Actually, it looks like a sinus wave. And maybe we are looking at it and we have some idea. Okay, it looks like it works good here it is. But maybe some other places it's better to shift this wave, this declination wave on some amount days to get better results. Of course, you can do it using log function. You see, here it is. But we can do it easy, better. We can build, if we consider this as a sinus wave, we can build a cosine wave using speed of declination. You see, speed of declination. Let's calculate together declination and speed of declination, how declination changes. Okay, let's calculate both these functions and look at this in panel. This is red, this is declination. Blue, this is speed of declination. Okay, when declination passes 0, it's, you see, a speed of declination close to max value, exactly like sinus wave, cosine wave. When declination reaches max value, speed of declination is always equal 0. Here it is, and passes 0 from top to bottom. When declination value passes 0 from up to down, speed of declination is negative, max negative. So here it is. So you see, these functions are not exactly harmonic functions. but their looks very different. They work very different. So they are close to orthogonal functions, not exactly orthogonal functions, but they are close to that. Accordingly, you see, building combination of these functions, we can build shifted declination function. In other words, we can build declination model this way. Just send these events to events box model or to simple Euler model. Clicking this button here, there, and now I will build. Just a second. I will set it to target optimization. Target I will set it to because it's faster cycle. Okay. And now I click optimize. So now program has found the weights for declination and weights for speed of declination to get the better fitness with projection line. I copy this data to this text into clipboard, and then I will put them there, here. So this is superposition of, look at this, this is the best from point of view statistic, declination, wave based on declination. Just this is weights for declination, this one, weight for speed of declination, this one, and we can check how it works. Maybe it does not work. Just an example. I don't know exactly how it works. I will set click start, continuous. Oh, by the way, it works. It works. It's almost 6%. But yeah, it works. Okay. Full declination model is ready, but now let's build a more advanced model. Full declination, full moon model. Let's apply. Maybe you see. Maybe we can add the same way, not declination only, but also moon latitude. Of course we can. We can add position for latitude and position for speed of latitude. Okay, in other words, we will get a cosine wave for latitude and a sinus wave for latitude and a cosine wave for latitude, kind of. Let's calculate them together, and you see this is latitude, and they work exactly like sinus wave, cosine wave. It's max, 0, max, and so on. But what about maybe geocentric geoposition? Because you see, if we will add longitude, geolongitude, we will get something like that. You see this wave. This is actually not periodic function. This is just longitude, just how its phase changes. And to analyze longitude, we cannot apply longitude itself. We need to analyze. We can apply sinus wave for longitude. So, in other words, to get wave for longitude, we apply sinus wave, okay, cosine wave, and maybe we will add more harmonics. One harmonic, add two harmonic. So finally I will remove this one, we do not need that. And now we see we have sinus full longitude, cosines full longitude, sinus second harmonic, and cosines third harmonics. We can, of course, we can try to add more harmonics. We will get more detailed projection line. So now I will send these events into simple Euler to calculate weights here, there. And let's optimization. Okay, I will copy, Control insert, Shift insert. So this is weights for these terms. Okay, click calculate. You see, this is kind of a full moon model. We can calculate correlation. Yeah, correlation approximately the same, so it does not provide, does not give more information, but at least you should know how to do that. You can analyze any function this way. One more thing I would like to mention. You see, now I do this in a turbocycles model. In turbocycles model, you see by default it displays. I remove all of this. To remove all ULI events, click this button, this cross button. So all ULI events are removed now. So you see, now you see it displays projection line, and also you see I would like to calculate kind of if we consider it's a sinus wave, to kind of cosine wave. And this is a derivative of this rate of change. So this is like a shifted 90 degrees projection line. Not exactly shifted, just kind of, you see. And maybe it makes sense to watch these two projections lines together. Just regular projection line and rate of change for this projection line. Sometimes it works this way. So later it will be added this function for composite model and so on. Okay, thank you.